Today we start a new chapter. Chapter 6, this is titled Sequences and Series. Today we're going to be talking about sequences. And we're going to have some new vocabulary today because this is a new topic, totally new topic for you. Never studied this before. First of all, the vocabulary word sequence. A sequence is a set of numbers written in a given order. So order is important with sequences. For example, here's a sequence, 1, 2, 4, 8, 16, 32. They have to be written in that order. Each number in a sequence is called a term. In the above example, the first term is 1, the second term is 2, the third term is 4, the fourth term is 8, the fifth term is 16, 1, 2, 3, 4, 5, the fifth term is 16, and the sixth term, or is the last term, is 32. So these are each called a term. And the terms of a sequence have a notation of the letter lowercase a with a little subscript of an n. And this little number n represents which number term it is, and we call it the nth term, like the 7th term or the 6th term or the 5th term. The n represents the number of terms, or the term number. In this above example, the first term, you write it as A1. The first term is 1. And this is how we say it. The second term is 2, the third term is 4, the fourth term is 8, the fifth term, which is written as A with a subscript of 5, the fifth term is 16, and the sixth term again is a 32. There are a couple different kinds of sequences. Finite sequences. Finite means they end. So finite sequences contain a last term, and infinite sequences repeat without ending. So sometimes sequences go on and on and on. This example up here is a finite because it contains a last term. But an infinite sequence has ... after the last term. For example, 3, 6, 9, 12, 15, 18, ... is called an infinite sequence because it never ends. If you want to write the terms of a sequence, you start with n equals 1 in the given rule. Now there's something called a rule for sequences or a formula in order to get what term you want. And then you're going to continue until you've written the terms asked for. Now you can use a graphing calculator to list the terms of an explicit sequence. If you want to put y equals, or you press the y equals button in your calculator and look at the table of values, you can see all of the terms in the y column. The y value represents the term. An means the term, or the nth term. So what we're going to do is we're going to write terms of these sequences down here. Here's a definition of a sequence. This definition says the nth term is 5 times n minus 3. So we're going to write the first 5 terms. So here's the first term, here's the second term, here's the third term, here's the fourth term, and here's the fifth term. So we're going to write them as A1. The first term is 5 times 1 minus 3, which is 5 minus 3, which is 2. So the first term is 2. The second term is 5 times 2 minus 3, which is 10 minus 3, which equals 7. The third term is 5 times 3 minus 3, whoops, I didn't need that parentheses, is equal to 15 minus 3 is 12. The fourth term is 5 times 4 minus 3, which is 20 minus 3, which is 17. And you can kind of see the pattern here going 2, 7, 12, 17, and I bet you can guess the next term. The next term is A5. A5 is called the fifth term, so it's 5 times 5 minus 3. 5 times 5 is 25 minus 3 is 22. So there are the 5 terms, the first 5 terms, 2, 7, 12, 17, 22. These have explicit formulas, so we're going to write down the first 5 terms of sequence number 2. So this explicit formula says we take 2 and raise it to the nth power. So the first term is 2 to the first, which is 2. The second term is 2 to the second. Now n equals 2. 2 squared is 4. The third term is 2 to the third power. 2 to the third is 8. The fourth term is 2 to the fourth, which is 16. And the fifth term is 2 to the fifth. Oops. 2 to the fifth, which is 32. So you can kind of see this pattern. 2, 4, 8, 16, 32. It keeps getting doubled and doubled, or 2 to the nth power. So if we want to write the 100th term, we can do 2 to the 100. Same thing over here. If we want to write the 100th term, it's 5 times 100 minus 3. 500 minus 3, 497. If we wanted to, but we don't. So this one has terms, the first term, the second term, the third term, the fourth term, and the fifth term. We're only writing 5. We could write as many terms as we wanted to. So this one has -1 to the nth power divided by n. So how do we write this out? Well, we take -1, now n equals 1, so we raise it to the first power, all divided by 1. So here's your first term. -1 to the first power is -1. -1 divided by 1 equals -1. So there's your first term. The second term is -1 raised to the second power divided by n is 2. -1 squared, -1 times -1 is +1. +1 over 2 is a half. So the second term is a half. The third term is -1 raised to the third power all over, now n is 3. -1 times -1 times -1 is -1 over 3. The fourth term is -1 raised up to the fourth power divided by, now n is 4. Well, -1 to the fourth power, -1 times itself 4 times is +1, and then we have a 4 in the denominator. And then the fifth term is -1 raised up to the fifth power, all divided by 5. Well, -1 raised to the fifth power is -1. So these terms go -1, a half, -3rd, +4th, -1/5, and you can kind of see a pattern developing there. So you can figure out what this pattern is if you wanted to write them all out. Now, like I said, if you wanted to put these into y equals in your graphing calculator, example number 1, 5n minus 3, you can just do 5x minus 3. Look at the table of values. And we don't have a 0th term. We never start with 0, but we start with the first term. Here's the first term, second term, third term, fourth term, fifth term. So we can get any term number we want. In the second example, we had 2 to the nth power. So 2 raised up to the x power. If you want to look at the table of values, you start with n equals 1. So these are the n values, and these are the terms: the first term, the second term, the third term, the fourth term, and the fifth term, the sixth term, and you can go all the way up as far as you want, the 10th term. And then example number 3, alpha y equals, and now we're taking -1 raised up to the x power, and we're dividing it by x. So if you wanted to take a look at those terms, look at the table of values. Oops. The first term, second term, third term, fourth term, fifth term, sixth term, seventh term. So you can always use y equals to write out your term numbers if you have a formula. So now, instead of us being given the rule, we have to find out what the rule is for these sequences. Sometimes they're tricky. So what we're going to do is write the next term in the sequence, and then write an algebraic expression that represents an. So these kind of get tricky. So here's you can usually see the pattern: 10, 20, 30, 40. The next term would be 50. That's the next term. And how do we get these terms? What would the explicit formula be? How do you get the nth term? Well, this is how I do it. I put the term number above each term. So here's the first term, here's the second term, here's the third term, here's the fourth term, here's the fifth term. And after I get the term numbers, I ask myself, how do I get a 10 out of a 1? How do I get a 2 out of a 20, a 3 out of a 30, a 40 out of a 4, and a 50 out of a 5? How do I get these numbers, a 10 out of 1? I think if I just multiply the term number by 10 times n, I think that would give it to us, right? The first term is 10. The second term is 10 times 2 is 20. So this is 10 times n. Here's the next one, 2, 4, 6, 8, but they're all negative. So the next one would be negative 10. And I'm going to put a 1, 2, 3, 4. And then here's the fifth term. These are the term numbers. I write really small above it. So how do I get all these numbers out of these numbers above? Well, if I multiply negative 2 times each one of these numbers, which are the n numbers, these are the n values. So the nth term is equal to negative 2 times n, right? Negative 2 times 1, negative 2 times 2, negative 2 times 3, for example. Here's the next one, a little bit trickier. 10, 1,000, or 100, 1,000, 10,000. Well, you just keep on tacking another 0 on. So this one has 1, 2, 3, 4 zeros. So the next one have 5. 1, 2, 3, 4, 5 zeros. 100,000. Here's my first, second, third, fourth, and fifth term. 10 to the first, 10 to the second, 10 to the third. This is scientific notation. 10 to the fourth, 10 to the fifth. Oh, all of these are 10 raised up to the nth power, because all of these numbers that I wrote smaller n, so 10 to the nth power would give you each one of those numbers. All of these numerators are 1, so my next term also would have a 1 in the numerator. But the denominators go 5, 10, 15, 20, 25. 25. And then we can kind of see what the pattern is in the bottom. Like if I put a 1, 2, 3, 4, 5, those are the term numbers underneath. The nth term, there's always a 1 in the numerator. You don't change that. It keeps a 1. But under here, how do you get a 5 out of a 1, and a 10 out of a 2, and a 15 out of a 3, and a 20 out of a 4, and a 25 out of 5? Well, you multiply those n numbers by 5. So 1 over 5n. The next one, look at the numerators, 3, 4, 5, 6, 7, and look at the denominators, 4, 5, 6, 7, 8. There's the next term. And how do I get? Here's the first term, the second term, the third term, the fourth term, the fifth term. How do I get a 3 out of a 1, and a 4 out of a 2, or a 5 out of a 3, or a 6 out of a 4, or a 7 out of a 5? How do I get from those numbers up here to those numbers down here? Well, maybe you've guessed. I hope so. You add 2 to all these numbers to get up to these numbers. So on the top it would be n plus 2. And how do you get to these denominators from these numbers here? Well, you just add 3, 1 plus 3, 2 plus 3, 3 plus 3, 4 plus 3, and 5 plus 3. So this is n plus 3. So there's your definition for that one. And then 6, 7, 8, 9, 10 on the top, 1, 2, 3, 4, 5 on the bottom. So actually you would probably write this as a 2 instead of 10/5. So here's our n, 1, 2, 3, 4, 5. So the denominator looks like these values are just the same as the n values. So I'm going to put my denominator down first. And if you just add 5 to all of these, 1 plus 5, 2 plus 5, 3 plus 5, 4 plus 5, 5 plus 5. So this would be n plus 5 all over n. So there's your definition. Sometimes terms of some sequences can be computed from the previous term. If this is the case, the sequence is called recursive. This is a real important definition for you, the recursive sequence. If you are given a recursive sequence, you will be given the first term. The first term is called a sub 1. And then you're going to be given a formula to compute the other terms using the previous term. For example, here's a recursive definition. It tells you the first term. The first term is 20. Then it gives you a definition. So here's your first term, and then underneath it, it gives you a definition. This means the next term. If you have a n plus 1, this means the next term. So the next term is equal to the previous term plus 5. So this an is that previous term. The next term is the previous term plus 5. So there's a recursive definition. So if you want to determine the second term in this above example, the second term is called a sub 2. You're going to let n equal 1 in this definition. So n plus 1 is 1 plus 1 is equal to the previous term plus 5. This is a little bit more difficult to explain than it actually is to do. So what you're going to do is take the previous term and add 5 to it. So the previous term is a 20. 20 plus 5 is 25. So the first term is 20. The second term is 25. The third term, you're going to let n equal 3, and you're going to get the third term, which is 2 plus 1. Whoops. I'm sorry, you're going to let n equal 2, not 3. You're going to let n equal 2 in the recursive definition. So n plus 1 is a2 plus 1, which is a3. a3 is the second term plus 5. So whatever term you're trying to get, the next term is the previous term plus 5. So the previous term, the second term was 25, so 25 plus 5 is equal to 30. So the third term is 30. The fourth term, which is a sub 4, you're going to let n equal 3 in the recursive definition. So 3 plus 1, this is the fourth term. The fourth term is the third term plus 5. And the third term we just figured out to be 30. And 30 plus 5 is 35. So that's how recursive definitions kind of look scary or complicated, but all it is taking whatever you're given, the first term, and add 5, and then continuing to add 5 to all of the previous terms. So we're going to write the first 4 terms out in a line. So the first term is 20. The second term we calculated to be 25. The third term we calculated to be a 30. And the fourth term we calculated to be 35. So those are your first 4 terms, and you could probably figure out all the rest of the terms in this sequence. Now there's an easy way to do this if you want to use your graphing calculator to list all of the terms of a recursive sequence. What you're going to do is type the starting value or the first term and press enter. So in this example, and you're going to do that out in the main screen. So the starting value is a 20. That's the first term, and then you're going to hit enter. And then you're going to use the ANS key as the formula to generate the sequence. So you're going to do that is going to be your previous term plus 5. So this ANS is actually the previous term plus 5. So there's your second term. And then you can just keep pressing enter to get to the next here, and then you can press it as many times as you want to get to the next term. I'm not doing anything except pressing enter and pressing enter, and keep pressing enter, and you'll get that. So let's clear that out, and I'll show you again. You type in a 20, whatever your first term is, and hit enter. And then second negative is ANS. You see the little blue ANS, second negative. So then the recursive definition says you're going to add 5. That's the previous term. And then you're going to hit enter, which will give you that 25. And like I said, just keep hitting enter. Hit enter, hit enter, and just keep hitting enter. And you keep going up the recursive sequences. So how do you do this in these last 2 examples on this page? We're going to list the first 5 terms. Well, the first term is 2, and we want to get the second term, and the third term, and the fourth term, and the fifth term. Well, the next term is 2 times the previous term. So 2 times the previous is how this definition goes. So the 2 times the previous, which is 2, is 4. The third term is 2 times the previous. So that goes there. 2 times 4 is 8. The fourth term is 2 times the previous. The previous term is 8. And then the fifth term is 2 times the previous term, which is 32. And if we wanted to do that on our calculator, we press a 2 and hit enter. And then we do 2 second negative, ANS. So there's your next term, and then just keep hitting enter, 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 and you can get all the terms you want all the way up. And then this last example for the day, the first term is 81, and the next term is a third of the previous term. So the second term is a third of the previous term, which is 81. 1/3 of 81, I think, is 27. The third term is 1/3 of the previous term, which is 9. The fourth term is a third of the previous term, which is 3. And the fifth term, hopefully you can see this okay. And the fifth term is 1/3 of the previous term, which is 1. So this definition just says take 1/3 of the previous term. So you just keep on using the previous term in your definition. If you wanted to use your calculator, you start with an 81 and hit enter. And then you do 1/3 of second negative, which is ANS. There's your second term, and keep hitting enter, 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 enter. So you just keep getting more and more terms. That's it for today.